Okay, so this video is going to be our second and final video for Unit 4, Day 6 for geometry. In it, we're going to answer these two EQs because they kind of go hand in hand. But let's start with this first EQ. We're going to talk about, well, what is surface area, right? And surface area, to put it literally, is the amount of two-dimensional space, we can say, covering a 3D figure. Okay, so to put that into perspective, let's go into the third essential question, right? And real fast before I go, uh, so EQ2, another way to say that is so imagine a prism or whatever, right? You can think of this as two-dimensional perimeter. Okay, you'll see what I mean here in a second. Okay, so how can we calculate surface area, right? So to put it simply, you calculate surface area by calculating the area of each surface. And we call the surfaces faces for short, right? So calculate the area of each face, right? And add them up and add, right? So in our do now for this lesson, we talk about a figure that has these three dimensions, and I'm going to go ahead and draw it here. So our x dimension we say is equal to 45 meters, right? Our y dimension is 20 meters. Try to scale that a little better. So 20 meters. Draw little arrows to kind of show what I mean by this. Okay, and then we say our z dimension is 60 meters. Okay, so kind of putting this into perspective, right? This is a pretty large figure. Okay, now if I wanted to know, well, how much surface area does this occupy, right? I would have to break this down into multiple surfaces, right? So let's look at it. So we have this front surface, right? And that front surface is identical to what we can call the back surface back here. Okay, so that means I have two surfaces that are 20 for y and by 45, so 20 by 45 for x. And I have two of these, okay, the front and the back. Okay, so now let's start thinking, well, what other surfaces are there, right? And in the do now, we refer to this particular prism that we see that I'm drawing here. We refer to it as a rectangular prism, right? So we know there must be more to this. So there's also this wall, we'll call it, right? If this is a building, we'll call this the left wall. And we know this wall directly across from it is going to have to be the same, right? So there's two of these surfaces, and these surfaces would be 20 by 60. Okay, so two surfaces that are 20 by 60 instead. And these are in meters. Right? Okay, and we'll also have to take notes. So that's four surfaces now, but we also have to take notes. So if we're talking about a building, right, which in the do now it is, we have to account for the floor, right, and the ceiling. Okay, so in total we have six surfaces. So the floor and ceiling would be 45 by 60 now. Okay, so a much larger surface. Okay, so 45 meters, and that's our x dimension, by 60 meters. That's our z dimension that we call it. And there's two of these surfaces, right? So what we're going to want to do is just add this all up. So there's two of the front and back walls, right? So two of these, and obviously we would find its area by multiplying our two dimensions, 20 times 45, plus two of our right and left walls, right? And our right and left walls are 20 by 60. So two of 20 by 60 plus, ran out of room here, our floor and ceiling. So two of 45 by 60, right? And we just add that up. Okay, and I don't have my calculator ready. I have a really bad habit of doing that. Like, I know I'm going to need the calculator in the video, and I just completely forget to boot it up. And of course, it takes it a minute. But I'm just going to sit here and rant while we kill time. And there it goes. So now I begin the fun part of trying to move this over here without messing it up. All right, there we go. So I am going to do none of that and just use a scratch pad. Okay, so two of the 20 by 45 added to two more surfaces that are 20 by 60 and added to two more surfaces that are 45 by 60. Okay, and we see that we have a surface area uh, of 9,600 meters squared. Okay, so that would be the surface area, the amount of area, right, that covers a three-dimensional figure. In this case, this rectangular prism here. And we can also think of that as two-dimensional perimeter. We're literally wrapping around, finding how much surface can wrap around some figure. Okay, so it's very similar in that way to perimeter, except we obviously add a dimension. Okay, so surface area is a very simple concept to understand. It's not much more difficult than perimeter, honestly. Um, just a little more tedious in its calculation. If you have any questions about surface area, obviously let me know or send me an email. Come find me. Goodbye.